So we just have 3 weeks left till Thanksgiving. So let's pop this up on the screen, see what we're looking at this week as we're getting down to the end of the semester approaching pretty quickly. All right, Algebra 2. Well, let's go to our grade screen as usual, see where we're at. So when we go to the grade screen, we see that last week we had the sum and difference of cubes and the graphing quadratics. Those were fun lessons we had. This week we're completing the square and solving quadratic equations, which fortunately we've solved quadratic equations for. So hopefully a lot of that may be review, but maybe we'll add a twist or two that you haven't seen before. And then next week we're finishing up this module. We're testing next week. And then we'll have 1 week before Thanksgiving after the test. So next week's testing, so let's finish up completing the square and solving quadratics 3.05, 3.06. Let's see what it teaches us today. Completing the square. Make sure I got some paper ready for this. Okay, we have a video to start out on completing the square, and it looks like it may have some of these little funky cartoon people that they like to throw in these videos. A minute and a half, we have time for that. We can do a minute and a half video. Little cartoon video, I'm sure.
Devin and Kristen are both in the Florida Virtual Symphony Orchestra. The orchestra chose them because of their vast musical talent. Devin plays both the cello and percussion, and Kristen plays both the cello and the flute. Let's listen to them play. Yikes! Something is not quite right. I think I know what is wrong. The percussion section is not complete. Devin, can you switch to percussion? Go over here. Now we still need another cellist to keep the orchestra balanced. We can take away one person from the flute section. Kristen, can you switch to cello? Go over here. I think we're ready to try again now. The conductor added Devin to the percussion section because he knew it would make the orchestra sound better. The addition is just what they needed to complete the orchestra. This is similar to a mathematical process called completing the square. Some equations are difficult to graph at first, but after moving some parts around, they suddenly become easy to graph. Continue reading the lesson to learn more about completing the square.
Okay, so completing the square, completing the orchestra, I don't know. All I know is that, switch this back. All I know is it looks like every time they showed Devin, it looked like he just sat down in some ice cream or something. So he was having a time there. Okay, after completing this lesson, we're going to be able to answer these questions. How can completing the square aid in solving quadratic functions? And what indicators predict that a quadratic function will have a complex solution? Remember, a complex solution means imaginary. Anytime you see complex, think of imaginary. Rewriting the vertex form of a quadratic equation to general form. All right, we've looked at some of that in the past. We'll do another one. We'll use their example right here. Let me put that on paper so we can have it in our notes. So the vertex form of a quadratic equation looks like this, right? Where this is h and k. You know, it's f of x equals a times x minus h squared plus k. Right, that's the vertex form where h and k is the vertex. All right, so if we had something like this and we wanted to put it in standard form, remember standard form of a quadratic is a squared. Oh, a not a squared. I'm getting ahead of myself. A x squared plus bx plus c. And when it's at that form is when we can use the quadratic formula. So if we have it in vertex form and we want to put it in this form, because maybe we know that it's going to have imaginary solutions, and that's when we need to use the quadratic formula. All we have to do is simplify this. Use math to go through the order of operations and simplify it. So the first thing we need to do is deal with the exponent, which is saying this is x minus 5 squared. So we would rewrite this as 2 times x minus 5 times x minus 5 minus 3, right? Because that's what it means to square something. It means you're multiplying it by itself. Now we'll distribute. So we'll leave the 2. Let's multiply the x times the x squared, x times the negative 5. Now let's distribute the negative 5 into both terms. Negative 5 times x, negative 5 times negative 5. And then we still have the minus 3. So we didn't do anything with the stuff outside the parentheses. We just multiplied those two together. We can simplify this because we have like terms. 2 times x squared minus 5x minus 5x minus 10x. Okay, we've done everything inside the parentheses. Now let's distribute. 2 times x squared is 2x squared. 2 times negative 10x is negative 20x. And 2 times plus 25 is plus 50. And we have minus 3 still out here at the end. So finally, f of x is equal to 2x squared minus 20x plus 47. And this is the same equation that is right there. All right, so we have the standard form from the vertex form by just simplifying it. Order of operations. Let's go back to our lesson. So that'll go through the whole steps right here. It says, the vertex we know is negative 5, positive 5, negative 3. We know the axis of symmetry is going to be at h, x equals 5. We know the domain will be all real numbers because the parabola is an upward facing parabola and will go forever left and right. Having the 2 out front means it's a narrower parabola. It makes it a little skinnier going upwards. The range is going to be everything above the negative 3, right? Because the vertex is going to be at 5, negative 3, and that's the lowest point of the parabola. So it's all the y's that are greater than or equal to negative 3. And then the y-intercept we get from the standard form. So since we had the fancy form, or you can substitute 0 in for x and calculate it. But 47, since we found the standard form, we already knew that this was the y-intercept because the y-intercept happens when x is 0. So if x is 0, that's equal to 0 and that's equal to 0. It just leaves the 47. So, okay, and then there's a review on converting, which we just did, converting from vertex to standard. They take the exact same equation that we just looked at, go through all the steps, distribute it, and get to that same 2x squared minus 20x plus 47. Because the equation will be manipulated on both sides of the equal sign, the function notation of f of x has been placed with a y. So let's learn how to convert the quadratic equation to vertex form, starting with this. So this was a little different. So now we're going to go backwards. What if we just had the standard form and we wanted the vertex form? We're like, oh, that's going to be a little trickier, right? So here's what we're going to do. Let me do this on paper if I can remember all the steps. It's been a while since I've done this. This is my first class this year to get back to. Oh, they said we're going to change this to y because we're going to be doing the math on both sides. Y equals 2x squared minus 20x plus 47. Oh, and I wrote 74. It's like I'm mathematically dyslexic today or something. Okay. So the first thing we need to do is move this to the other side. So they've got y minus 47 equals 2x squared minus 20x. All we did is subtract the 47 and move it to the other side. So now we do the step 1 that we usually do when we factor things, greatest common factor, right? So we can factor something out of this. So y minus 47 equals a 2. I'm going to leave the x squared because we need that for what we're about to do. Uh, I'm just factoring out a number. I'm not trying to pull out any variables because I need the variables in here. So I can factor out a 2 to leave this x squared minus 10x. Now at this point, we're going to try to make this into a perfect square trinomial. Remember what a perfect square trinomial was? That means if we have like x plus 1 squared, that would be x squared plus 2x plus 1. This is the perfect square trinomial get by squaring this. So we're trying to create this. So how do we do that? What we have to do is we have to take that middle term, negative 10, and we've got to divide it by 2. And whatever that equals, we're going to square it. It's like, what? Yep, that's what we're going to do. So here's what we got. We got y minus 47 equals 2 times x squared minus 10x. And then we're going to take this, negative 10 divided by 2, that's negative 5, squared, and we're going to add 25. But we have to do that on the other side as well. If we don't do it on the other side as well, we've changed the equation. So how much did we add to this side? Well, you might think right off the bat, well, we just added 25 to that side. No, we didn't, because everything inside the parentheses is being multiplied by 2. We've actually increased this side by 50, 2 times 25. So we have to add 50 over here as well, because now it's the same equation. Without the plus 50, this isn't equal anymore. This one actually is 50 more than this side is, because they started out equal. And as long as I do the same thing to both sides, right, I subtract 47 from both sides, then they're still equal. Here I just factored one side, but I didn't change how much it's worth. That's still 2x squared plus minus 20x. I just wrote it differently. Now I've added 50 over here because I've added 2 times 25. So I have to add 50 over here. So now I've got y plus 3 equals, and this is a perfect square. This is actually x squared minus 5 squared. Oh, I'm sorry, it's not x squared minus 5 squared. It's x minus 5 squared. How do I know? Because this equaled negative 5. And then I squared it to get this last term. Negative 5 is what I get when I divide the middle term by 2. So that's what this is. Now, if we want to say, do we know that's the same thing? Well, let's check it. I said that x minus 5 times x minus 5 is the same as that. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x and negative 5 times negative 5 is 25. So this is x squared minus 10x plus 25. Yeah. So this is 2x minus 5 squared. All we have to do is move this over, subtract 3. Y equals 2 times x minus 5 squared minus 3. This is the vertex form of this. And we know that's true because that's what we started with up here when we went the other way. We started with the vertex form and we got down to the standard form. Then we started with the standard form and worked backwards to get back to the vertex form. And these are the same number, 2x minus 5 squared minus 3. So that's how completing the square works. What square are we talking about? We're talking about the perfect square trinomial. That's what we're trying to complete. We're trying to make this a perfect square trinomial so that we can rewrite it as the binomial squared. So we're trying to figure out what number would we need to put on the x squared minus 10x to make that a perfect square. And we do that by taking the middle term, dividing it by 2 and squaring it, and that's the number we add on. Just remember, if there's anything out front, though, that we factored out, that has to be taken in consideration when you balance it out on the other side. They have to work on both sides. So they go through all those steps here as well to get to the 2x minus 5 squared minus 3. But that's why they use the y instead of the f of x. Important note, once the equation is isolated the y variable again, it is appropriate to replace the y with f of x again, just to put it back in function form. F of x equals 2x minus 5 squared minus 3. Although that's a very minor part of the whole process. All right, clarification on why you divide the middle term by 2 and then square it. So a perfect square trinomial, if you remember when we talked about that before, has a middle coefficient that is equal to twice the product of the square roots of the n terms. The opposite of doubling a number is dividing it by 2. So the opposite of taking the square root is squaring the number. So if you remember when we looked at that, twice the product of the square roots of the n terms. The process of creating a squared binomial is called completing the square. We're creating a perfect squared trinomial by squaring a binomial. It's a little overwhelming, but the more you practice this, the more it's like, oh, I get it. I get it. So we're gonna look at these 5 right here. Let me make them bigger on the screen. So if we're going to complete the square, and this is what we have, and we're like, okay, I need to complete the square. I need to make this a perfect square trinomial. Tell me the number, and I'll open up the chat. I'm looking in the chat. Tell me the number that we would need to add to make this a perfect square. And remember, the way we do that is we take the middle term, which is right there on the screen, cut it in half and square it. Cut it in half and square it. So what number are we putting in the blank? If we've got x squared minus 2x, Daniel says 1. Anyone else? Anyone else? Everybody else totally lost? All right, I see some more ones. I'm like, please don't tell me you're struggling with the math of dividing -2 by 2 and squaring it. Since -2 is going to be the middle term, you cut that in half. So -2 divided by 2 is -1. And when you square -1, it's 1. Excellent. All right, let's try another one. 8x squared plus 8x plus something. What goes in the blank? Like Jaden had a little Spanish flair with his answer last time. That's nice. Nice touch. Yeah, please don't do this one in a Spanish flair, though. I don't know Spanish numbers for 16 there. All right, got some 16s. You're like, 16, you just double the middle term? No, you don't double the middle term. You cut it in half and square it. But when you take 8 and cut it in half of 8 is 4. And 4 squared is 16. Very nice. All right, how about this one? X squared minus 14x plus some unknown number that you're about to tell me. We got one answer quickly. X squared minus 14x plus. What do you got, folks? Need to make sure more people are attending class and not just left the Chromebook here. Elijah's got an answer there. All right. Let's get at least 2 more. Thanks, Driven. Thanks, Mary. Yes. -7. When you cut -14 in half, you get -7. And when you square -7, you get 49. So cut that in half, square it, submit. Yes, that's a perfect square trinomial. Oh, let's see. Are they doing something different? Fill in the blank with the number that completes the square. Nope, same thing. X squared plus 24x plus something. Oh, Madison's on this one quickly. Madison's, I got it. 24. We cut it in half. That's 12. 12 squared is 144. Wonderful job. And here's our last one. x squared plus 30x. Oh, they're getting bigger every time, aren't they? X squared plus 30x plus wah wah. We'll see who's reaching for their calculator right now. Ah, you guys are pretty quick on that. 15 squared, right? 225, 15 squared. Hopefully a lot of you knew that in your head, but if not, at least you was able to get there. 225. Very nice. So now we're going to get ready to apply this exercise to rewriting quadratic equations from standard form to vertex form. Shrink this back down and go to the next page. Page 2. All right. Before rewriting these functions, evaluate the discriminant. Remember we looked at the discriminant we looked at that back in the last unit when we were systems of equations. We're looking at it, actually 2 units ago, I guess, and now we looked at it some last week. Remember the discriminant, if it's 0, there's going to be 1 rational solution. If it's a positive perfect square, it's going to be 2 rational solutions. If it's a positive number that's just not a perfect square, like 7, you'll have 2 irrational solutions. So they'll have some like 3 plus the square root of 7 or something. And if the discriminant is negative, we got 2 imaginary solutions or complex. Remember when you see complex, think imaginary, 2 complex solutions. Okay. Rewrite. Let's see. Show me. What's it saying? The formula for discriminant is b squared minus 4ac. Absolutely. So if we check this one, x squared plus 12x plus 26. Let's write this one down. X squared plus 12x plus 26. Checking that discriminant first. B squared minus 4ac. B is 12. So 12 squared minus 4 times A is 1. C is 26. 12 squared is 144. 4 times 1 is 4. 4 times 26 is 104. That was quick to calculate because 4 times 25 would be 100. And you just add another 4. So the discriminant equals 40. So we know it's not a perfect square. So this is not going to have 2 rational solutions, but it will have 2 irrational solutions that are not imaginary. But let's work on finding the vertex form. So we're going to change this to a y. X squared plus 12x plus 26. I'm going to move the 26 to the other side. So we got y minus 26. I'm going to leave a little space there. Equals x squared plus 12x. All right. We don't have any number to factor out this time. Remember, we can factor out an x, but that doesn't accomplish what we're trying to do. So no number to factor out. So we need to find what number makes this a perfect square. So this is 12. We divide it by 2. That's 6. So we square that, and it's 36. So we got to add 36 to both sides. To both sides. Now, what number did we get here? When we divided that by 2, that tells us, let's see, negative 26 plus 36. So this is y plus 10. This would factor into x plus 6 squared. We know that because 6 was the number that we used to get the 36. Whatever this is divided by 2 will be the number. Let's move our 10 over. So y equals x plus 6 squared minus 10. Or as they like to do at the end, they like to put this back in function notation. F of x equals. So our vertex is going to be at negative 6, negative 10. Because remember, it's x minus h. So if x minus h equals x plus 6, h must be a negative 6 because it'd be x minus negative 6, and that would be x plus 6. So negative 6, negative 10 is our vertex. And this is the answer back in vertex form that they wanted us to find. By completing the square to make x plus 6 squared. Let's see, isolate the terms with the x's, which they did that by moving the 26 over. Completing the square by adding the 36 that we came up with. Simplifying that to y plus 10 equals x plus 6 squared. Then when they move the minus 10 over, you get x plus 6 squared minus 10, which is what we came up with. Then they check it by multiplying it back together to get back to the original. All right, so using the vertex form, minimum or maximum. So for this example, the x plus 6 squared minus 10, does this look familiar? Yes, this is the vertex form. So we know the vertex is negative 6, negative 10. Wrote that on our paper. But is the vertex a minimum or a maximum? So does this parabola point up or point down? Is that vertex the lowest point on the parabola, or is it the highest point? Remember, you look at the leading coefficient, which in this case, we have it for both. I mean, we have the original equation right here. It's a positive 1. So this parabola goes up. This is also a positive 1 out front. This parabola goes up. It's not a downward parabola. So this vertex is going to be a minimum value. And we can actually graph that. So let's put the original equation first. Y equals x squared plus 12x plus 26. Oh, look, there's the vertex. Negative 6, negative 10, and it is a minimum. Everything is higher than that. Let's graph the vertex for them just to make sure we hit that right. X plus 6 squared minus 10. Yep, exact same graph. So you turn the blue one off, the red one's there. It's the same graph. Just a good way to double check yourself is to graph them both forms and make sure it's the exact same graph. Should be. So let's see, doing the discriminant again. Okay, here's another example on writing quadratic in vertex form. Let's see, I don't know which one would be more interesting. Let's look at the answers just to see which one might be more fun to work. I think we'll do this one. You can go through that one if you want. I'm going to click and do this one that's in the box. So let's look at another example for our notes. All right, so we're looking at this one right here, x squared minus 18x minus 27. I've already wrote it in y equals. So let's move the 27 over. So that gives us y plus 27. And again, I'm going to leave some space for whatever we add on there. Equals x squared minus 18x. But that's gone now. So we need to take the negative 18 and divide it by 2, which is negative 9, which already tells us this is going to be x minus 9 squared if we do this right. Minus 9. And then we square that. Negative 9 times negative 9 is a positive 81. So add 81. Add 81. So this side is y plus 27 plus 81. That's 108. So we subtract that from both sides to put it back over here. So y equals x minus 9 squared minus 108. So the vertex is at 9, negative 108. That's a long ways down there. But that's where the vertex is, 9, negative 108. So let's double check ourselves by graphing this. I'll start with the original. So the original form was y equals x squared minus 18x minus 27. Woo! Yeah, the vertex is way down here. And where is it? It's at 9, negative 108. Yay, that's what we came up with in the vertex form. So we have done that correctly. Simplify. Y equals x minus 9 squared minus 108. Okay, so again, this may look kind of weird, but the more of these you do, the easier it gets. It's just simply move whatever the constant is and then figure out what this last term has to be by just dividing it by 2 and then squaring it. And then that becomes your new squared binomial on that side. All right, page 3. Chip saw an infomercial last night that was selling a product that can be used to cut an avocado into squares if you have a need for that. Very tempting, but with limited drawer space, there is not room in Chip's kitchen for a tool that only does one thing. Chip can only have appliances that serve multiple purposes. So completing the square is a tool that's stored in your brain, and the good news is it has multiple purposes too. It can convert the standard form of a quadratic into vertex form, and it can also find solutions to a quadratic equation. So just like before, check the discriminant. So it says solve by completing the square. All right. So first thing is to check the discriminant. So we're going to do that right here. B squared minus 4AC. So B is 6. So 6 squared minus 4 times 1 times 8. So 36 minus 4 times 8 is 32. So we're going to have 2 rational solutions because 4 is a perfect square. 2 real rational solutions. All right. So starting out, completing the square, we'll just set it equal to 0. Set it equal to 0 instead of setting equal to y. And complete the square. So we got x squared plus 6x. So we're going to cut that in half and square it. So we're going to add 9 to both sides. 6 divided by 2 is 3. 3 squared is 9. We're adding 9 to both sides. 9 over here and 9 over there. So now x squared plus 6x plus 9 equals 1. Since we had negative 8 there. Now we need to factor that. And that's x plus 3 squared equals 1. And we can solve it from that point right there. Because we can square both, take the square root of both sides. Take the square root of both sides. X plus 3 squared. Square root of that is just x plus 3. And then you have the square root of 1, which is plus 1 and minus 1. So that gives us 2 solutions. One is when x plus 3 equals 1. So the solution equals negative 2. And also when x plus 3 equals negative 1. So the solution is negative 4. That gave us the 2 real solutions. And you can check those by substituting in the negative 2 and see if it equals in the equation. So let's try one of those, solving it using this. We still got some paper left. All right, so we have this problem here. Let's check for our answer first. B squared minus 4AC. So negative 6 squared is 36 minus 4 times 1 times 6. 36 minus 4 times 6 is 24. So it's 12. So we're going to have 2 solutions, but they're not going to be integers. But they will be rational solutions. I mean, irrational solutions, but they'll be real numbers. So the first thing we're going to do is move the 6. So that gives us x squared minus 6x and leave some space equals negative 6. Okay, completing the square. Negative 6 divided by 2 is negative 3, which means this is going to be x minus 3. And when we square that, we get plus 9. So we'll add that to both sides. So x minus 3 squared equals 3. So now instead of trying to set it back in vertex form, we're actually trying to solve it. So we're trying to get x by itself. So let's take the square root of both sides. So the square root of something being squared cancels each other out. We just have x minus 3. And over here, the square root of the square root of 3 is just plus or minus the square root of 3, which is a decimal number. We can find that with a calculator. But if we want to be more accurate, we leave it like this. So this is our two solutions. You're like, two solutions? I see one. Yeah, but there's two numbers right here. One is a positive, one is a negative. So let's write our two solutions. One of them is when x minus 3 equals the square root of 3. Positive. So if we add 3 to both sides, there's one solution, x equals 3 plus the square root of 3. The other solution is when x minus 3 equals negative square root of 3. So when we add 3 to both sides, x equals 3 minus the square root of 3. So that's the two answers. 3 plus the square root of 3 and 3 minus the square root of 3. It told us we was going to have two irrational solutions. But if you're dying to know what number that is or what two numbers those are, we can get an approximate by using the calculator. 3 plus 3 square root. So this one is about, I'm going to make a little about symbol there, 4.732. That's about what that solution is. This one is about, the little swirly there, 3 minus the square root of 3. So this one's about 1.26. If we do it to 3 decimals, it'd be about 8. So let's graph this then and see if that's actually where it crosses the x-axis, right? Because that's what we calculated. And that's what the zeros would be, is where it crosses the x-axis. So we said it was x squared minus 6x plus 6. Okay, we're way down here in the negatives. All right, let's zoom in here. We said the answer was positive 1.268. Well, there it is, positive 1.268. And the other solution was 4.732. So we were able to find the answers. They're just irrational. They're not integers by completing the square. Okay. Lesson summary. Oh, there's another example down here. If you want to work another one, and here's the third one right here. Plenty of examples for you to try that they will show you the answers. Here's our lesson summary. Steps. Oh, love having the steps. Steps for changing a quadratic equation from standard to vertex. First, isolate the terms containing the x. So move the constant. Complete the square and balance the equation. Make sure you do it on both sides. Simplify. Combine like terms, factor the perfect square trinomial, isolate the y, and then you can check your work by multiplying back together. And remember to check the discriminant, and there's what the discriminant tells you again. We've been looking at that several times this semester. Steps for solving is very similar. You can isolate the terms with the x variables, complete the square and balance the equation. Divide the coefficient on the x by 2 and then square it. Add the other side of the equation as well. Then you combine like terms and factor the perfect square trinomial. Solve for x. There is a page of practice problems, as you would expect. Okay, write each of these in vertex form. So here's the one you can work on paper, put it in vertex form, and then fill in the answers. What's y equals, what's a number before the x, if there is one? What's the number in parentheses with the x, and what's the number on the end that's added or subtracted? And there's another one there. So, and there's 4 on example 1, and there's 5 on example 2. And this, you're solving it. Complete the square and solve, select the correct answers. And there's more than one answer. There's 2 answers. Let's look at the assignment that goes with this lesson. Determine the vertex of this function. And it's in vertex form. Thank you. All you got to do is just look at it and then choose the right answer. Which of the following values completes the square for this? X squared minus 12x plus what? If that's a negative 12x, what's that going to be? Using the complete the square method, write this in vertex form. Find the vertex form. Using the complete square method, find the vertex form of this and say, is that a maximum or minimum? Where's the vertex? There's the vertex, and is that a maximum vertex or minimum vertex? And then solve this by completing the square. And it's irrational solution as well.
Introduce yourself.
All right. Let's look at our second lesson,
Excellent. Jalen, come back, man.
solving quadratic equations. Let's see how they're having us do it. We just learned how to do it by completing the square. Let's see what we're going to look at this time. While redesigning her backyard to build a pool, Nadia wants to include a rectangular garden that has an area of 35 square feet. Due to the size of her yard and the incoming pool, the length of her garden must be 2 feet longer than the width. How wide and how long will the garden be? While setting this problem may seem easy, solving it may not. So to help her with the dimensions, you need to have knowledge contained in these upcoming pages. So let's play with Nadia's problem just a little bit before we look at those pages. Area equals 35. And it said length equals 2 feet longer than width. Okay, we can play with that. If the area is 35 and the area is found by multiplying the length times the width, if we say the width is x, then the length is going to be what? 2 feet longer than the width. So it's going to be x plus 2. And that's all going to equal 35. So if you multiply the length, the width times the length, it's going to equal 35. So if we multiply those, we get x squared plus 2x equals 35. Look, that's a perfect completing the square type problem. Cut this in half. That's 1. Square it plus 1 plus 1. So this is going to be x plus 1 squared equals 36. So if we take the square root, the square root of x plus 1 squared is x plus 1, because square root and squared cancel each other out. Square root of 36 is either 6 or negative 6, right? Could be either one. So the two answers are, if x plus 1 equals 6, then x equals 5. If it's negative 6, x plus 1 equals negative 6. When you subtract 1, x equals negative 7. Now, since this is, x is the width, right? We made the width x. And we get two answers. One's 5, one's negative 7. What are we talking about? We're talking about her garden and length. So in that case, we automatically throw this one out because she would not have a width of negative 7 feet. Since it's a real life situation, we have to look at that and go, oh, wait a minute, this is not reasonable. So the width is 5 and the length is x plus 2 or 7. And 5 times 7 is 35 square feet for the area. That's the only difference when solving, is you have to pay attention. Do I need to throw out one of the solutions because it's a real life situation where the solution makes no sense? Absolutely makes no sense. Okay, solving a quadratic equation by factoring. So we can do that. We know how to factor from both sides. So ever since learning about square roots, you've known how to solve second-degree equations by taking the square root of both sides. So if x squared equals 9, then x equals either 3 or negative 3. That's the two solutions, because you take the square root of both sides. The other way to solve that, subtract 9 from both sides, you get x squared minus 9 equals 0. And we looked at that a few lessons ago. This is the difference of squares. Difference of squares. So you know your solution is A plus B times A minus B. So that would mean this would factor to x plus 3 and x minus 3 equals 0. So the answer again would be 3 or negative 3. Same solutions. So 0 times any number of variables, 0 product. Okay. So yeah, 3 plus 3 and x plus 3 and x minus 3 equals 0. So you set them equal to 0 individually. First factor could be 0 or the second factor could be 0. If the first one is 0, x minus 3 equals 0. Or the second factor could be 0. So it could be x plus 3 times 0 equals 0. So both factors could be 0. So you just set them equal to 0 and solve them. So either 3 or negative 3 is the solutions. And they work all the way through that.
Yes, Maddox has it.
And then you can graph it, x squared minus 9. X squared minus 9. Oh, helps if I actually click on the box there. And we see the two solutions are negative 3 and 3. Same thing we can find algebraically, we can find them by graphing them. Very nice. Okay, let's go to page 2. I'm going to say we've done a lot with quadratics over the years here. Remember the factor tree? There's many branches of factoring quadratics that we've looked at. Finding the greatest common factor, perfect square trinomials. We've done difference of squares. We've done grouping and factoring trinomials. And now we've learned completing the square. We've got a lot of different ways to climb that tree. These methods are the branches. So to get to the roots, you got to pass through the discriminant. That's where we check the discriminant to get to the roots. So it tells us whether it's going to be real rational solutions, whether it's going to be real irrational solutions, or whether it's going to be imaginary solutions. Is it possible to solve x squared equals negative 4x without setting it to 0? That's a good question. Solve x squared equals negative 4x. See what they say. You'd have to take the square root of both sides, which would give you x equals, but you'd also have an x under the square root. So that doesn't provide a solution. It really doesn't. So the only way really to solve quadratics is you need to set them equal to 0, because that's what you need to know. When is the x equal to 0? Because that's when it's on the x-axis, when it's an actual 0 of the solution. So in this case, adding 4x to both sides, let's write some of this down. They're going through a lot on the page. So it said if we have x squared minus 4x, equals negative 4x, says, can you do that without setting equals 0? No, you really can't. You need to add 4x to both sides. This is how we solve quadratics. We set them equal to 0. This, we can actually factor out the greatest common factor. So it's x times x plus 4 equals 0. So either x equals 0 or x equals negative 4. That was the solutions to x squared equals negative 4x. Because either x equals 0 or x plus 4 equals 0. So x would be negative 4. And if we want to test those, let's test 0 first. 0 squared equals negative 4 times 0. Just substituting 0 in for the x. And that equals each other because it's 0 equals 0, right? Because they do equal each other. How about when x equals negative 4? So this would be negative 4 squared equals negative 4 times negative 4. Well, isn't that what negative 4 squared is? Negative 4 squared is 16. And negative 4 times negative 4 is 16. So both of those answers check out. So they wrote it in standard form. They checked the discriminant. The discriminant was 16, which is a perfect square, which means we're going to have two integer answers, which we did with 0 and negative 4. So they factored out the x, said each factor equals 0, x equals 0, x plus 4 equals 0. Subtract negative 4 from both sides, subtract 4, and you get 0 and negative 4. And then they checked them just like I did. 0 equals 0, 16 equals 16. Or you could even graph it. Negative 4 and 0. Note that there were two solutions to the equation in the previous example. What part of the original equation, x squared equals 4x, might indicate how many solutions there will be? It's the largest exponent. It's the x squared. And by the way, that's not the right equation. Ours was negative 4x. Theirs is positive 4x. But still, that one would still have two solutions because the x squared is the largest exponent. Okay, solve this one. Write it in standard form, factor it, set each factor equal to 0. Let's take a look at their video on solving quadratics by factoring.
Yes. Okay, so I'll capture, okay?
This is 14 seconds.
Something's in the picture.
The first step in the solution process is to write the given equation in standard form. Gather all terms on the left side of this equation to keep the x squared term positive. That leaves 0 on the right side.
Tell me what letters you got.
Here's step 2, a little longer.
The second step is to factor the quadratic expression. Notice that the terms 6x squared, negative 33x, and 45 are all divisible by 3. Factor this GCF from the equation. The GCF of 3 will remain on the outside of the parentheses. To factor the remaining trinomial, multiply the leading coefficient of 2 and the constant term of 15. Find factors of 30 that sum to the middle coefficient of negative 11. You can organize the results in a table. Negative 5 and negative 6 fit both sides of the chart, since negative 5 times negative 6 equals 30, and negative 5 plus negative 6 equals negative 11. Rewrite the middle term of negative 11x as negative 5x and negative 6x. Separate the polynomial into two groups, the first two terms and the last two terms. Factor the GCF from the first group. 2x squared and negative 5x have an x in common. Factor the GCF from the last group. Negative 6x and 15 are both divisible by both 3 and negative 3. So which do you use? If you were to factor 3, the remaining binomials would not be identical. Notice that the binomials 2x minus 5 and negative 2x plus 5 are not identical and, therefore, cannot be considered a GCF that may be factored. Instead of using a GCF of 3 for the last group, try using negative 3. Now there is a common binomial between the two terms which can be factored.
Okay, step 3. Here we go.
The third step is to apply the zero product property by setting each of the factors equal to 0 and solving. There are 3 factors being multiplied. They are 3, 2x minus 5, and x minus 3. For these factors to result in a product of 0, 1, 2, or all of them must equal 0. If the first factor of 3 is set equal to 0, the equation 3 equals 0 is created. But 3 can never equal 0. This is a false statement and will not be considered in the final solution. However, the other two binomial factors can be solved to find a solution. When the factor 2x minus 5 is set equal to 0 and solved, the result is x equals 5 halves. When the factor x minus 3 is set equal to 0 and solved, the result is x equals 3. The solutions to 6x squared equals 33x minus 45 are x equals 5 halves and x equals 3. The equation has a degree of 2, and there are 2 solutions.
And finally, step 4, checking.
The final step is to check the 2 solutions. Substitute both solutions into the original equation to check for accuracy. First, Substitute 5 halves for x. Square both the numerator and the denominator. Simplify by dividing 6 and 4 by 2. Write the integers as fractions with 1 in the denominators. Multiply the numerators and multiply the denominators. Subtract 165 halves from both sides of the equal sign and simplify. The equality indicates that this solution is correct. Now, substitute 3 for x in the original equation. The final result after simplifying is a true statement. So 3 also checks out as a correct solution. Graphing the parabola y equals 6x squared minus 33x plus 45 also serves as a check. The two solutions, 3 and 5 halves, or 2.5, are indeed the x-intercepts of the graph.
All right, so that walked through factoring, solving quadratics. Here's more examples on doing it by factoring. If you struggle with factoring, you may want to go through some more of this. Some more of these examples. So there's example 2, example 3. There's 3 examples there for you.
Red, yellow, pink, purple, blue.
Page 3. The history of the quadratic formula. A long time ago, math was used in a very structured method. There were not any formulas, there were not any equations, there was not any functions. Mathematicians had to use tables. So if the city engineer wanted to build a room that had a specific area for storing grain and pottery, the city engineer would consult a large table that gave the dimensions. However, the ancient Greeks started observing math through an abstract lens. They wanted to create rules and formulas that would be true in all situations, even if it wasn't listed on their big, gigantic book of tables. So people like Pythagoras and Euclid would lay the groundwork for this masterpiece today that we call the quadratic formula. They would travel through China, Egypt, the Middle East, and India before finally ending up like we see it today. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. They look a little complicated. Yeah, it can be, but it's really, you just put in the numbers and solve. So, the blue part is the negative b over 2a. If you recognize that, that's how we found the axis of symmetry in standard form of a quadratic equation. For the parabola, you can find the axis of symmetry. And the discriminant tells us the solutions we're going to have. So it's interesting. That's the pieces, the negative b over 2a and the b squared minus 4ac. So let's see how it's used as a whole here. So ax squared plus bx plus c. We'll look at their quadratic formula. The 28-second video here. It has 3 steps though, so we'll have a few videos again.
The first step is to write the given equation in standard form. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. As with solving quadratic equations by factoring, the equation needs to be in standard form, so the correct values for a, b, and c are used. For this equation, subtract 9 from both sides to get the equation in standard form.
All right, let's go to step 2.
The next step is to factor any GCF that might exist. The coefficient of the first term is 1, so there is no numerical GCF greater than 1 among the terms. The last term does not have a variable, so a common variable doesn't exist. Therefore, there is no GCF that will change the expression when factored.
All right, so finally it's just applying the quadratic formula.
The third step in the process is to apply the quadratic formula, then simplify. For this equation in standard form, a is 1, b is negative 4, and c is negative 9. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substitute the values for a, b, and c into the quadratic formula. To avoid making a sign error, make sure you use parentheses around each substituted value. Using the order of operations, simplify the exponent first. Negative 4 squared is 16. Continue the order of operations by multiplying the appropriate integers. Combine the expression inside the radical. Now, simplify the radicand. 52 can be written as the square root of 4 times the square root of 13, which becomes 2 times the square root of 13. Rewrite the fraction as two separate fractions and simplify by dividing by 2. Make sure your solutions are left in radical form.
And that's the solutions. 2 plus or minus the square root of 13. You want to leave that in this form. If you write it as a decimal, it's wrong because you had to round it. So you do not have the exact answer. You have an answer that's very, very close. That's not the right answer because the square root of 13 is a number that does not have an ending. You have to round it at some point if you're writing that. There's another example there. 3x squared minus 11x minus 6. You got to set it equals 0 by moving everything to one side. Factor out anything you can factor, which in this case, you have a 3 and a 6, but you have an 11, so you can't factor anything again. So you just put the numbers into the quadratic formula. So we'll work this one together so we have an example on paper of the quadratic formula. So let me switch screens. So we're going to move everything to one side. So we set it equal to 0. So we add, since those are subtracted. So now this is 3x squared plus 11x plus 6 equals 0. Now again, greatest common factor. We have a 3, we have an 11, and we have a 6. Nothing factors out of that. So this is A, B, and C. So remember the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So x equals negative 11, because b is 11, plus or minus the square root b squared. So 11 squared minus 4 times a, which is 3, times 6, which is c, all over 2 times a. So x equals negative 11 plus or minus. Okay, so this is 121. That's what 11 squared is. 4 times 3 is 12, times 6 is 72. So it's 121 minus 72. So this equals 49. And 2 times 3 is 6. I didn't have to write that so long, did I? Because we simplified it. So what is the square root of 49? Well, 7, plus or minus. It's already got the plus or minus. So x equals negative 11 plus or minus 7 over 6. So that's our two solutions, but we need to simplify them and break them out. So one solution is x equals negative 11 plus 7 equals 6. And the other one is negative 11 minus 7 over 6. See, one's with the plus, one's with the minus. Negative 11 plus 7. So that equals negative 4 over 6, which is negative 2/3. Negative 2/3. Negative 11 minus 7 is negative 18 over 6, which that simplifies to negative 3. So there's our two solutions. X equals negative 2/3 and x equals negative 3. Using the quadratic formula. Let's see what they got. They got negative 6. Oh, wait. Oh, that's checking their solutions. I'm sorry. Here's what their solutions are. Negative 2/3 and negative 3. That's the same solutions we got. Negative 2/3, negative 3. And then when they check them and put them back into the formula. They end up right. All right. Review and factoring. Another example here using a real life equation. Basketball player throws the ball from 6 feet off the ground at this velocity. So it gives you the equation for that. The height when the ball hits the ground is equal to 0. Substitute in the solve. So it says, how long does it take the basketball to hit the ground? So since they gave you the formula, it hit the ground when it equals 0 height. So you can use the quadratic formula, and it'll give you plus or minus negative 20 plus or minus the square root of 520 over negative 10. So that means you have one answer at negative 0.28 seconds or at 4.28 seconds. So then you got to think, okay, how many seconds does it take to hit the ground? It's not going to hit the ground in negative seconds. I'm throwing that answer out. You throw that out, and you just use the answer that's the positive number. In 4.28 seconds, it'll hit the ground, not in negative 0.28 seconds. All right, lesson summary right here. Talks about what methods can be used to solve quadratic equations. Solving a quadratic equation by factoring. Here's the 4 steps. Using the quadratic formula. You rewrite it in standard form, factor any GCF, and apply the quadratic formula. 3 steps. And checking your work. Okay, they've got 2 pages of practice problems for you. This one has 10 problems. Solve this one. 10 problems. Then on the next page, we have 10 problems there. So there's 20 practice problems. Do you have to do them all? No. If you've got the hang of it, you've worked the first 4 or 5, and you're like, okay, I'm going to skip that one because I already got it. I'm not missing any of these. I understand it all. Okay, great. Don't do them all. But if you're struggling with it and you're getting wrong answers, you should continue practicing. Look at our assignment. Okay, solve. Gives you quadratic equal to 0. Solve. This one's equal to 2. You got to set it equal to 0. Which of the following is a solution? So what are the solutions? Which of these is a solution? Okay, 5 problems. There you go, guys. Completing the square, which is another method to solve quadratic equations. And then quadratic equations, lesson on solving that. So, got any questions? I'll be here Wednesday, but Friday is a B day. So, have a great week. We're done.